car started from rest as usual. The car started from rest. The question says the car started from rest and accelerated uniformly for 3 minutes. It is 3 minutes. 3 minutes is accelerated uniformly for 3 minutes. For 3 minutes. Uniform for 3 minutes. Getting to a speed of 50 kilometers per hour. So 50 kilometers per hour. 50 kilometers per hour. 50 kilometers per hour. At 3 minutes. At 3 minutes, you get a speed of 50 kilometers per hour. Gets the speed of 50 kilometers per hour. It continues at this speed for 6 minutes. It continues at this speed for 6 minutes. About 6 minutes. That means this is 9 minutes. For 6 minutes, it continues at this speed for 6 minutes. It continues at this speed. And then decelerates uniformly for 4 minutes to come to rest. It decelerates uniformly for 4 minutes to come to rest. That is 4 minutes. This will be 13 minutes. 9 plus 4. That is 13 minutes. So, now the question, we have look at the diagram. The diagram has been shown. There's a question, what does the question say? Therefore, the question says, what is the total distance traveled by the car for the whole journey? That's the area of this. The area of this. It says, what is the total distance traveled by the car for the journey? The average speed of the car. That's what the question wants. The acceleration of the car. That's the acceleration of the car. Then the time taken for the car to go half of the distance traveled. So to start with, since we are working with kilometers per hour, I can change everything there to hours. So I have, this is 3 over 60. This is 3 over 60 hours, which is equal to 1 over 20 hours. I want to change to hours. Then the next one is 9 minutes. 3 over 20 hours. This is 3 over 20 hours. That's 9 over 60. 9 over 60 hours. I'm changing the minutes to hours. This is 13 over 60. This is 13 over 60 hours. If I'm working in hours, since this is in kilometers per hour. So it's just to get the area of this. If I get the area of this, I get the total distance traveled. So for me to do that, it's simple. Area of the trapezium. Total distance traveled, the area of the trapezium, that's 50 over 2, bracket from here to here. That's 1 over 10 hours. That's 1 over 10 hours. That's from here to here. 1 over 10 hours plus the whole of this, which is 13 over 60. 13 over 60 hours. That will give me the total distance traveled. Total distance traveled, which I got to be 7.92 kilometers. This is equal to 7.92 kilometers. 7.92 kilometers. I changed this minutes to hours. So I have gotten the distance, the total distance traveled, that's the area of the trapezium. Then the average speed is total distance traveled divided by time, which the time taken. So it is total distance traveled is the average speed is total distance traveled over time used in doing the travel. And the time used in doing this travel is 13 over 60 hours, which is 7. So it will be total distance traveled 7.92 divided by 13 over 60. So it will be 60 over 13, which in this case is equal to 60 over 13, which is 0.77 meters per second squared. That is 36.54 kilometers per hour. 36.54 kilometers per hour. 36.54 kilometers per hour. That is the average speed. That's the average speed. That is the total distance divided by time. The acceleration is the distance divided by the velocity. The The distance divided, that's the average acceleration. That's the whole distance, which is the whole the velocity divided by time. The velocity divided by time. Because if you watch when it was accelerating, as it's accelerated for 3 minutes, it accelerated for 3 minutes. So if we can divide the velocity by the time, we get acceleration. So acceleration is equal to, this is 50,000. If I want to change it, that's 50 kilometers per hour. I can decide to change it to 50,000 meters. I divide it by time, which is 3 minutes, which is 3 times 60. That would be 3 times 60 seconds. 3 times 60. So if I divide this to get the acceleration, I get like this, I got 0.77 meters per second. 0.077 meters per second. That is per second square, sorry. That's the acceleration. I got the acceleration. That's what the question required. The question now say, to get the distance traveled, they said the time taken by the car to go half of the distance. We already know the total distance now traveled. The time taken for half of the distance. Half of the distance traveled is 3.96. That is half of 7.92. The half of distance traveled is 3.96. The space for traveling that half distance, if you take it as x, that's if you have this half of the, okay, here, let's say from here to here, the space from here, this space, this is 3 meters, this is 3 minutes, but from here to here, we don't know, we call it x. So, and this is still 50 kilometers per hour. So we call this x. The half of the distance used to, the space or the time used to travel half of 7.92 divided by 2. That's the half of the distance traveled, which I got that half to be 3.96 kilometers. That's the distance traveled. The distance traveled, which is this. So that if we get the area of this trapezium, this small trapezium, we equate it to 3.96. If we equate it to the area to 3.96, so if we want, we can say this distance, or this is 3. Here is 3. So from here to here, if we take this as x, this is x. The whole of this is 3 plus x. So I say the area of this trapezium will be, for example, is x plus 3 plus x times 50 over 2. This is equal to 3.96. That's the area of this. And that's the total distance traveled, because we want to get the time used to travel half of the distance. If we do that, we get x from here. If we work this, we get x. And in that case, we got x equal to 3.252 minutes. If you solve this, you get an x is equal to 3.52. It's equal to 3.252 minutes. That is x. But the total distance is x plus 3. So if you add 3 to this, it gives you, so total distance used to travel half of the total time used to travel half of the distance. Total time used to travel half of the distance is this plus 3, 3.5252 plus 3, which is 6.252 minutes. That was what used to travel all total distance. So the question, let me repeat the question. A car started from rest, and accelerates uniformly for 3 minutes, getting the speed of 50 kilometers per hour. It continues at this speed for 6 minutes, and then decelerates, come down uniformly for 4 minutes to come to rest. distance traveled by the car, the area of the trapezium. That's A. B. What is the average speed of the car? What is the average speed of the car? Total distance divided by time. Total distance traveled by time. That's the second question. The third, what is the acceleration of the car? Here, the velocity divided by time. What is the acceleration of the car? D, the time taken by the car to go half of the distance traveled. The time taken to come here, this is the half of the distance, just half of this trapezium, which is 3.96. And the distance from here to that half, we don't know, we call it x. Then that means the total of this is x plus 3. If we now get x plus 3, so we get the area of this trapezium, which is x plus 3 times 50/2. Simple. And we weighted to the value of the half of the distance traveled, and we get x. When we get x, we added it to 3. We get the total distance traveled. So that's the question. Says a car started from rest, accelerates uniformly for 3 minutes, getting to a speed of 50 kilometers per hour. It continued at this speed for 6 minutes, and then decelerates uniformly for 4 minutes to come to rest. A. What is the distance traveled by the car for the whole journey? B. What is the average speed of the car? C. What is the acceleration of the car? D. What is the time taken by the car to go half of the distance traveled? And then everything is on the board there. Done. Thank you very much.